Free response question number 1, part A. Let R and S in the figure above be defined as follows. R is the region in the first and second quadrants bounded by the graphs of y equals 3 minus x squared, y equals 2 to the x. S is the shaded region in the first quadrant bounded by the two graphs, the x-axis and the y-axis. You can see the two regions graphed on the picture. Part A, find the volume, find the area of S. So S is right here. We have two different things happening. So we've got this as the upper boundary here and this as the upper boundary here. Or if you were thinking about a dy, you have this as the right-hand boundary here and the right-hand boundary here. But then we have this equation as the left-hand boundary here and this as the left-hand boundary. So either way you do it, you're going to have to use two integrals. So since both equations are in y equals form, it benefits us to use a dx. So we have a dx here and a dx here. So area, very simple, is upper boundary minus lower boundary. So the integral on the left, I'm going to integrate from 0 to, well, whatever this point of intersection is. So right now, I'm just going to call this a comma b. The point of intersection will be at x equals a, so I'll go from 0 to a, and I will take that upper boundary minus the lower boundary. So the upper boundary is the y equals 2 to the x, and the lower boundary is 0. And integrate with respect to x. Then I'm going to add to that the second one. The integral is going to go from a, which we'll find on the calculator in a moment, to this value, right? So what is that value? That's the 0 of 3 minus x squared. So on the side, if I take 3 minus x squared and I set it equal to 0, I get that x squared is equal to 3, which means that x is plus or minus root 3. So that would be from a to root 3 of the upper boundary minus the lower boundary. So once again, 3 minus x squared minus 0 with respect to x. All right, so now let's find those intersection points. So on your calculator, you will type in the two equations. So you'll go to y equals, and you'll type in 3 minus x squared, and then you'll type in 2 to the x power. So now if you're on your standard viewing window, zoom 6, you get this picture. We may want to change the window. Let's make it from -3 to 3 and -1 to 3. Let's see how that looks. So now we get our region. So now we want to find the intersection, but there are two intersection points. So when I hit second trace intersect, number 5, first curve, yes. Second curve, yes. Now, guess, I want to pick something close on the right, so I'll choose 1. It happens to be 1. So that point of intersection is 1, comma 2, which means that a is 1. So you could just write a equals 1, or you could just put integral from 0 to 1 and 1 to root 3. Either way will get you full credit. All right, then the other intersection, I will need that later, so let's find that. Second trace intersect, first curve, yes, second curve, yes, but then remember you want to guess something over there. It looks like it's close to like -2. So I'll type in -2 and I get that intersection. So I'll go over here and I will write down that intersection point. So -1.637. So -1.637, comma, and then the other point would be 0.322. So 0.322. All right, so now my first integral, so remember we said that a is 1 and b is 2. If you state that somewhere, then you don't have to change your integral over there. So now what we want to do is we want to do this calculation. All right, so what is this calculation? So let's go back to our calculator. So now our calculated value. So we want to type in the integral. So math number 9. The function is 2 to the x, comma, with respect to x, comma, 0, comma, 1. So we'll calculate that value and then add it to the next value, math number 9. And the next function is 3 minus x squared, comma, with respect to x, comma, 1, comma, square root of 3. So now we add those two together, we get 2.240.